shows myself an 18,000 lumen retrofit laser module. It's still an engineering demonstrator, but it'll be commercially available in our C-Series projector at the end of this year. So it'll come out as a 20,000 lumen module. Take the lamp out of your existing 20C Barco projector and plug in the laser. The lasers are all inside. The module itself has a cooling system and power and controls. So anyone who's bought a C-Series projector recently can convert it instantly from laser or from xenon to laser. After that, we'll do our B-Series up to 30,000 plus lumens with a retrofit kit, and then eventually our S-Series, which are the smaller screen models, which is economically the most challenging conversion to make. Obviously, those projectors will be available with as new systems as well as retrofit. So that's bringing laser benefits, not all of them, but bringing a number of laser benefits to all screen sizes. In the premium format where we've been talking so far, we have 4 models of RGB from 60, 45, 30, and 22. So for people who want a premium screen in a VIP small theater, we have a 20,000 lumen RGB model that has embedded 6P 3D and does the other 3Ds as well. So the point being, Barco is all in on laser. We're going to offer the entire cinema market, and with our relationship with IMAX, the super premium segment as well, laser solutions.
What's the cost of retrofitting?
So the whole premise of the retrofit line, if you will, and the reason why we're sequencing it in the way we are, is that it will be marketed as a TCO neutral or TCO better total cost of ownership, lower total cost of ownership than a equivalent average brightness xenon projector based on the lifetime of the laser, which is 30,000 hours.
So you're saying the cost of replacing lamps over 30,000 hours is X, and the replacement module will be X or less than X?
The OpEx savings, which are no more lamps, lower power consumption, lower labor costs and so forth, plus the OpEx savings.
Is it roughly equivalent to the cost of the module?
Right. Now there's some qualitative benefits in laser that we don't talk about enough in my view, and that is constant brightness over a long period of time where your patrons see the same brightness level. So I'm not ready to say that it's TCO savings, but it's TCO neutral.
Bill, you know that the laser brightness, it degrades just like a lamp. It takes longer, but I mean, at the end of that 30,000 hours, it's only 50% the brightness of when it was new. But I think the one thing that's an issue with the blue laser phosphor projectors is the color gamut. And that's something that I think this panel should probably address for the audience is that blue laser phosphor projectors are, they're red deficient. And that's the color that people really see when they see a laser projector. So I'm struggling with this notion of going to a smaller color gamut. Definitely difficult to get DCI-P3 with a.
To be honest, Mr. Barco?
I would say that's not true. It'll meet the spec. We can meet the spec. Whether sorry about that, laser phosphor can meet the spec, DCI spec, P3 spec. Maybe saturation, the Z format is what you're referring to. So the saturation of those colors may not be, or may be slightly lower. But as far as the actual color space, it's met.
So here's how they do it. They throw away half the light to bring it into the DCI P3 color space, and then they say, yeah, this projector's capable of it. Then they install it in a movie theater and run it in native color mode to get the lumen output. The two things don't exist at the same time, though.
So wait, you're saying we take light out and then we.
Sorry, I'm not saying that you do it. I did see a laser phosphor projector in Asia last week, and it looked okay on the screen. The color seemed a bit off. And I asked the exhibitor after, what's going on here? And he said, I don't know, it's bright enough, isn't it? And I said, yeah, but the color gamut's wrong. He said, I don't know, that's just how the installer set it up. So he was getting over 8,000 lumens out of what I know to be a 5,000 lumen DCI P3 projector. And the way he was doing that, and he didn't even know it because that's how his installer set it up, was he was running it in native color mode. So he's not even close to DCI P3. It's probably less than Rec 709.
The CINERAMAX 6P lux that you can plug into any DCI is 130,000 for the 19.
Hold on, let's, I want to finish talking about this topic here, because
Well,
this is
I think,
important.
I can't speak because I wasn't there, I didn't see it, I wasn't in the conversation. Did it happen? I can't say that it didn't, obviously, but that is something that we as a manufacturer would never, ever represent to our consumer, our exhibitor. That, I mean, we put filters in there in order to create the color space that's required. We follow specifications as they're laid out to us. If somebody at the location, in the exhibition location, makes a modification, then, and we don't know about it, then that's a possibility, but we
Sorry,
don't as
I wasn't meaning to blame the manufacturer.
We would never.
That's what's happening with the blue laser phosphor projectors that are hitting the street now. They're
But you
running
can
them
see it. You
out
can
in
see
DCI
it.
spec to hit brightness levels for bigger
Yeah,
screens.
but Don, you're really doing a disservice to what we're trying to talk about here. And
Am
to
I?
say that laser phosphor isn't going to play in cinema is just, it's insane.
Bill, I didn't say that. I said,
Well, you're taking
that there's a way to cut a corner here to use a projector in a much lower color space, a much narrower color space, to pump it brighter than it should actually be pumping. And that's what exhibitors have been doing with this
But
technology.
when the technology is matured and fully developed and released, you're not going to have to cut any corners.
I certainly hope not.
You can, as Rich says, you can meet the DCI spec, and you'll be able to meet it with a 10,000 lumen projector, a 20,000 lumen projector, and our prediction is with a 30,000 lumen
Your
projector.
18,000 lumen projector from CinemaCon, is that 18,000 DCI P3 lumens?
Yes, DCI P3 lumens, and it got rave reviews, and we showed polarization-based 3D with it, and it was retrofit.
So what are you
three
doing?
big
What are you doing
surprises.
with it?
So
No.
this is why we need to be able to
You need-
observe the
you had to be there.
sectors in the creative community to be able to understand how we have all these new light sources that are being introduced, but we're not getting a chance to really review it properly in the creative side.
So-
And so that, not because I think there needs to be a judgment here, but there needs to be feedback to manufacturers as to what is needed. And there need to be some feedback, there needs to be feedback,
And that's
obviously,
why-
to the exhibition community, how to set this up properly.
That's why we showed it to about 600 people at CinemaCon, which includes some of the exhibition.
But the thing is, you have to go walk, see Dolby Vision, then go see your thing, then cross the street to Cinemacanica. They're showing a barcode with 6P, and you're gonna say, well, the
That's why.
One,
we're
two,
gonna
three.
offer two image quality levels. One that's more focused.
but
on-
retrofit. Why isn't retrofit 6P? I don't understand.
Let's come back. I want to finish on the laser phosphor here. So tell us what barcode's done in laser phosphor, because if you use a standard yellow phosphor, it is going to be deficient in the red. There's no doubt about that. So
What do you mean? Do you mean it won't meet DCI P3?
Well,
Or
Rich
do you
just
mean
said
it
it
won't look
does.
like the Dolby Vision system?
The Star Wars
What if
looked a
you-
little bit purple.
Let me rephrase the question. What have you done in terms of your laser phosphor solution? Had you add a red phosphor or a red laser?
We wouldn't have committed to an early engineering demonstration 9 months ahead of release and shown it publicly if we didn't believe we could meet all the specs. I'll just put it that. I'm not gonna tell you
I'm
what's
not
inside the
questioning
box.
that. I'm asking you what the technical solution is. Tell me about that.
It's all blue laser. All the blue lasers are inside the lamp module, and it's phosphor based. That's what I can tell you.
You can't tell me anything about the phosphor though, I guess.
Not at this point.
Okay. Just want to be clear. Okay, now CinemaCanica is the other issue that you've raised, which is fine, because that's another retrofit solution that is being proposed out there as it's an all laser retrofit solution. It's currently going into a Barco product here. Now Barco's not affiliated with it, like it's the OEM Barco product and they retrofit. But I think this is an important point because I think there are going to be other manufacturers out there who develop laser-based solutions and will want to retrofit anyone's projector. I think that's probably going to start to drive some price competition in this market.
So I see two problems with the third party, and you guys will probably agree with me on this, two problems with a third party retrofit solution. And I saw their demo as well at CinemaCon. It looked reasonably good. But on a fiber coupled projector, you typically need a safety interlock. So the projector itself is shooting IR backwards down the fiber. And if the laser module doesn't see that IR signal coming down the fiber, it shuts off. And that's a safety interlock, so that if someone cuts the fiber or something, you can't spray laser light all over the room in people's eyes and things like that. So a third-party retrofit won't have that safety interlock. But also, more importantly, I mean, you're talking about putting 60,000 lumens into a standard prism light engine that hasn't been designed to handle that sort of light output. I mean, we have to modify the thermal handling in the light engine to handle 60,000 lumens. You can't come along with a third party who hasn't done that work to modify the light engine inside the projector. So I think there's two fundamental issues.
They can add cooling also inside the
They had
projector.
60 at their demo.
No.
Yeah.
Which
There
one?
were two modules sitting there.
I saw the 19, and I saw the Jurassic World right after Dolby Vision. And I said, wow, this is like 75% of Dolby Vision right here.
So there's no reason to go to a laser projector unless you want more brightness. But if you don't modify the cooling in the light engine, you're in trouble.
Oh my God, I don't agree.
It's a simple world, Chris.
So is it buyer beware?
Well, I mean,
Like there's no reason to give people your hidden menus that you don't use, for example, for panel registration.
It's
The
a
only
lot-
company that has, it's called the spatial color calibration. All the 4K chips have some kind of degree of color misuniformity. If you, the install projector, you take a reading at 25 spots and you send that to the factory, they'll send you a LUT file that corrects that and you're gaining like 15% more resolution. Only Barco has been doing that. Now I hear that Christie calls it PCP. NEC, it's hard to get calls back, so I don't know. So you're compromising. Don't compromise. This is a message I gave the same signal router guys. You need better lenses also in the 1.2 to 1.4 range, more resolution. What is this? People are using 1.2, the 2K chip lenses in that range. There is a huge market for like a small PLF, you know?
I guess you don't have that's not a question, you're making comments there.
I am, well, because he's saying they're cutting corners. I see them cutting corners unnecessarily. You need laser for the better color, absolutely.
To your retrofit question, and for 10 years at Laser Light Engines, we were venture capital based, so we had to address the biggest possible market, and it was all new and Wild West, so we developed fiber delivery retrofit solutions, universal retrofit solutions. It can be done, but I think there are a couple of points that will keep it, we'll slow it down, we'll put it that way. First thing is, and I'll speak for my own company, any warranty that the owner has will be voided if they put in somebody else's laser engine. So that's one impediment to retrofit solutions.
The mechanical warranties.
However,
The mechanic has to put out their own warranty.
right, they have to put out their own warranty. I'm not saying
That's the first part
that'll
of it.
stop it, but that'll slow it down.
That'll add the cost.
Don's point, I think, is extremely important, and I'm a fiber guy for 30 years, so I like the idea of delivering lasers through fibers conceptually. But as Don points out, it's dangerous. If you don't have the lasers inside an interlocked box, you have another level of, you lose a little bit of control. And although Christie, I think, has gone to great lengths to install the appropriate safety measures so that you don't have 600 watts of laser coming out of an optical fiber or optical fiber cable, which is enough to really drill holes through steel because it's not coming out this way, it's coming out as a pinpoint. That doesn't mean everybody will have the same safety measures. It also means that your safety measures have to talk to the given projector. And if the projector maker is not, designing that in the way Christie does, where they have both ends of the system, then
Potential problem.
it's a potential problem.
Well-
And as the co-founder of LIPA, spending 6 years on
Well, that was
trying
my
to
next
get
question. This
safety,
is,
get people comfortable with putting lasers into movie theaters, having a kind of a homemade retrofit fiber solution, which is easy to do but very difficult to do right, scares me because
well, how is it going to scare is it going to scare the FDA and violate all the?
there's FDA regulations for laser light shows. That's what got us into got them into the regulation business in the first place. But to my knowledge, there are not any building code regulations that regulate high power, hundreds of watts fiber optic cable. So it's uncharted territory. So I just hope everybody does it right and we don't have any problems.
Well, let me ask this: if someone in the U.S. retrofits a xenon projector with a laser-based third-party source, do they need to get an FDA compliant?
Well, not if you're a vendor.
Do you have to get a variant?
Got variants.
Absolutely. It's
Yeah.
a laser display product,
And,
it's subject
but
to
the retrofit has never been evaluated by the FDA, so what does that mean?
Differently, it hasn't been evaluated as a separate problem.
Right.
I think that may end up being the showstopper because the FDA is going to say, wait a minute, half of it is this guy and half of it is that guy, and who's responsible for the system?
Exactly.
So that's a good point.
I mean, to add to that retrofit solution, and I know as Barco is moving down that path, I think every manufacturer has probably studied it to some extent. I would imagine so. But you can't just throw a laser inside a projector. They weren't designed for that type of light entering the optical system. Where's that light scattered? There's nothing to take, you have to take that into consideration. So you can't just throw anybody's laser in the back end and say, okay, we now have a laser projector. Because internally to the projector, there's going to be the potential for that laser scattering around. Barco's probably addressed it in the first series of product that they're introducing, and part of the reason that they're moving slowly in introducing other series is the fact that they have to modify or come up with a solution to fix internally the projector so that there's not that laser scatter. So who's going to do that with a third party? Is the third-party companies that are creating laser modules going to come to each manufacturer and say, hey, can you help us design
Isn't it basically like a lamp
a
house?
different optical system inside?
Isn't it like a lamp house that
No,
goes?
it's not
not
like
that
a
easy.
house. That's the whole point.
Well, our retrofit system is.
But you've
But
done the engineering.
but you
designed
signed it
it
together,
together.
that's your point.
Right.
So, I mean, there's many things that have to be considered, let alone, the FDA looking into this as two different manufacturers building something that may or may not be authorized by the projection manufacturers.
Also,
So,
But the FDA is not looking at it.
it's a white point. It's a white light solution.
I mean, they obviously will.
Can we differentiate between discrete RGB and systems and white light to clarify? Like IMAX is discrete RGB, correct? Injection?
Any laser-based projector, whether it's 3-chip or 1-chip, has a red band, a green band, and a blue band. It's just a question of how narrow or broad the band is and what shape it is. So this notion of white light, if you combine all three colors into a fiber, it looks white and white light comes out the end. That's just the way you see it. But if you measure the spectrum of it, it's got a red band, a green band, and a blue band. So I hope that clarifies the terminology.
If there are no questions, by the way, please come to the microphone.
Can't.
Measurement's a fun topic.
2 nanometers.
How do we measure it?
The spectral bandwidth?
Yeah, it is a very important topic that the audience should be aware of. The simplest notion of a laser projector is a red laser, exhibit A, very narrow band, green laser and blue laser. So you have 3 narrow band RGB sources. And the next step would be 6 primary, where you have 2 red bands, 2 green bands, and 2 blue bands, also narrow, so you can separate them with glasses. That's not the way it is in the real world. There's a spectral power distribution of lasers, because you have multiple lasers in the, maybe even hundreds, maybe even hundreds of discrete devices. So you're going to have a distribution of red, a distribution of green, a distribution of blue.
That's good though.
That's good because it reduces speckle and it reduces the possibility of metameric variability. So that's what laser projector makers are trying to do. They're trying to get all the benefits of laser without the drawback, which is speckle and metameric variability. So in the future, you might see a spectrum of laser projectors that looks similar to one of a xenon. It just lasts for 30,000 hours and consumes less electricity. So that's, on the metrology side, because we have narrow band sources, the meters that were developed for xenon, which is broadband, sometimes are not appropriate. So you can have error in your measurements just in color point and brightness. So that's the first thing to take care of in metrology. The second big new thing with laser is speckle. And there's a fairly large committee within LIPA of about 25 members that have been working a year and a half to come up with a speckle measurement system that the industry will be able to use so they can compare different systems and screens and laser projectors. We hope to have that out as a draft recommended practice in a month or 2 so that the industry will be able to start to measure speckle performance on different projectors. So those are the two, for me, those are the 2 big metrology
well, the other,
watch-outs.
Yeah, the other potential thing is metamers, and you mentioned that briefly. But for those who aren't familiar with what this means, is if you illuminate an object or a screen in this case with a very broad source, the sun or a xenon lamp, most people will recognize those colors consistently. If you now narrow the illumination spectrum, i.e. with laser sources, you can get variability in the way colors are presented and are perceived by humans. The same color may be perceived differently by 2 different people with a very narrow sources where they would be perceived identically if you used a broadband source. So going from xenon to lasers starts to create these potential problems. So the colors that most people will see on the screen will be the same, but for some people it may change. And we don't understand the magnitude of this problem right now, or really how to deal with it, frankly. Do you agree?
So we don't have Matt Cowan here, but what Matt might say is that we would get metameric variability with any light source, and that doesn't remove the comment that you just made, Chris, that we don't know how to quantize that in the laser with laser projectors, and so that requires a lot more. That just requires more studies with eyeballs, and it's not something that's easy to do in a lab. That's the hard part.
Yeah. It's a perception.
Yeah, it's based on the statistical variability from person to person. So to do studies, you need a statistically valid sample, which means a lot of people looking at a lot of content to find out whether the problem is severe enough to design for. I think all of us are aware of it and have done our best to mitigate it, minimize it.
No one's complaining.
The type of problem that appears is usually a colored cast, or rather than a particular color looking different. you usually just see a shift in one direction. Because I've been with people who've experienced some metameric variability. We've had demonstrations where we've had different people sit and shout that they saw this kind of shift and that kind of shift. That doesn't mean that that's not marketable, that that's not a marketable product. So that's where, even if we have abilities to measure these things, we don't know what that means. That's the challenge. And I have the same problem with speckle. So if you come out with a speckle measurement, does that mean that this is not marketable below a certain threshold or above a certain threshold?
Good question.
There's a lot of, it's still not clear how to, on the marketing side on this, what's good enough and what's not. And so,
Well, I was there at Red with you when Barco showed the laser for the first. That was bad. That was bad. It's not an issue anymore.
And I guess the other question with metamerism is it's unclear. It's first of all, it's subtle, so it's not like some people see reds and people see green. It's very slight shades of these colors. So it may be that we don't even have a problem here for 98% of people. We just don't know.
My previous company, we did 10 demos, 2013. We did 10 demos in Burbank, and we did side-by-side xenon versus laser on a white screen and on a silver screen. And yes, there were people that said this doesn't match. I mean, the overwhelming majority of the people in the audience said the two matched. The meter said the two matched. But some said, no, it's a little red, and others said, no, it's a little green. I mean, so it exists, but it's too stimulus with a sharp line in between. So, the human eye is, in that sense, the human eye is very, very perceptive. But the amount of color difference in that example was within the error bar of the DCI spec. So as a single image, it's great. It may look a little different to this person or that person, but it's still. So our view is that it's real, but it's second or third order.
And as we heard yesterday, humans are good at seeing side-by-side differences in color. But if you showed them one image and then went to another image, they'd never see that difference.
Yeah, I mean, we're looking at it, as you said, the side-by-side, you have a way to compare it.
Right.
So if you know what one specific color is, and you see it compared to a different medium, in a sense, xenon versus laser, you may see that difference. But if they're just a single screen, more than likely you're not going to see that. So even if the color shift from one person to another is there, what realistically determines whether they're seeing the true red, true green, or true blue? There's not one of us in this room right now that can verify that anybody would see an incorrect color based on a single screen.
This is where friction occurs in the creative community side, is that cinema has been traditionally, for the history of cinema, has been this canvas by which it's the premier target for their content. That's the history of it. That's changed quite a bit in the last 10, 20 years. But still, it has that belief inside the Hollywood community that this is the target, this is the place where it should be exact. So when the P3 color space was developed by TI, that was done in the Hollywood community, side by side with film to match. And the STEM material, which is the test material that's publicly available for evaluation of digital projection, that material was color time side by side with film projection. So there was always a standard in the past, and so what is actually developed today is that it's fair to say that the TI P3 color space, as it was licensed, has become a standard to the cinematographer community today, and that's what they want to see. That's what they would call their standard today. Now, so we're in a world, we're stepping into a different place today where that may change, or that is changing. We have different light sources, TI is no longer has tight control over